Alrighty guys, so we are here. We're going to be talking about solving exponential equations. So we've done a bunch of work on IXL with logarithms, so we're going to be using those as well. All right. Now, if you take a look at this worksheet, I filled out the top already. If you want, you can pause the video and copy my answers, or simply use your calculator. All right. So here we are just putting in here, right? 2 to the second power, or 2 squared, right? 2 to the third power, 2 to the fourth power. So we're going to get 4, then 8, then 2 to the fourth is 16th, 2 to the fifth, right? 2 multiplied by itself 5 times is 32. Then we have 3 squared, which is 9, 3 to the third, 27, sorry. And then 3 to the fourth is 81, okay? And again, you can use your calculator. 4 squared is 16, 4 to the third is 64, 4 to the fourth is 256, okay? So you can always check these, like I said, on your calculator, all right? I don't really know 4 to the fourth off the top of my head, so I had to check that one, all right? 5 squared is 25, 5 to the third is 125, and 5 to the fourth is 625. Those might be numbers, maybe not the larger ones, but the smaller ones that you will be seeing today during the lesson and also on your homework, okay? So what we're going to move into now is we've talked about solving linear equations, quadratics by factoring. Now we're going to talk about solving exponential equations, okay? So if you take a look at all these, okay, you can see that there are superscripts, right? There are exponents here, and all the variables are in the exponents. So that's what an exponential equation is, right? The variable is in the exponent, all right? So we are trying to solve for the exponent, all right? And the example that they give you here is 3 to the x is 3 to the fifth, right? So the variable is in the exponent. If I take a look at this guy, right? Well, since they're both a base 3, then don't the exponents have to be equal? So therefore, can I kind of almost cancel or ignore the bases? And therefore, x, that exponent must be 5, all right? We're going to use that same principle. We're just going to have to do a little more math, okay? So if you take a look at this guy, all right, these both have a base 4. So since I have a base 4 on one side, right, and everything in the exponent with a base 4 here, I can cancel one base for one base, okay? And I'm going to get, right, 2 equals 9x minus 5. So now I'm just solving for the exponents, all right? I add 5. Right? And then I get 7 equals 9x, divide by 9. And sometimes your answers might not be pretty, and that's okay. X is 7/9, okay? Then here, this one gets a little more complicated, all right? And this is why I wrote this chart up here. And I want you guys to have this, you know, kind of available when you're doing your homework. 2 to the 3x, I can't, and is equal to 4 to the x plus 1. Well, the bases are not the same. However, if I look up above here, I know 2 squared is 4. So I can rewrite that base as 2 squared. Now I haven't changed the value, I've just rewritten it, okay? So now 2 squared replaces that 4. I bring down the x plus 1, okay, still in the exponent. And then this is 2 to the 3x. Now, since my bases are the same, after I've rewritten the 4, these can cancel, and then I'll have 3x equals, now what you have to remember is these two now get multiplied, okay? So we're going to have 2 to the x plus 1, okay? So you have to distribute that 2 to both quantities there. So this is going to be 3x equals 2x plus 2, right? Subtract 2x. And then we just get x equals 2 as our answer, okay? So this is a little harder. You have to have the same base, okay? So here we're going to rewrite with same base. Okay? And what you're going to see on the next page is you're always going to rewrite the larger base in terms of the smaller base, okay? So you can never make a base bigger, okay? You can only make it smaller, all right? So if you look at these guys, hopefully you recognize that this has a base 2, that has a base 2. So this is nice and easy. this has a base 3, that has a base 3. And then again, a number 3, base 5, so those cancel. So if we do like number 2, for example, I can cancel my bases. And since the bases are the same, one base for one base, I cancel. Then I get x minus 2 equals 5x minus 6. Then I would subtract x. You don't have to do this in the same order as me. You maybe will be doing it differently on the homework, but you subtract x. Okay, then you get negative 2 equals 4x minus 6. Add 6. And then we get 4 equals 4x. Divide by 4. So then x is 1, which is what we ultimately wanted our answer, right, to be. Just x, okay? So we're solving for x just like we normally would. We're going to use our 1 for 1, right? Canceling the bases. If the base is not the same, we have to rewrite it. So let's look at our next page, right? If you see, these are a little more complicated, all right? Because the bases are not the same. This is a base 10, that's a base 100. This is a base 6, 36. And then 2 and 16. So I can't cancel right now, all right? I need them to be the same. So I'm always writing the larger base in terms of the smaller base. So 2 to what power gives me 16? Well, you can use your calculator or you can go back to our trusty list here. 2 to the 4th power is 16. So I'm going to do 2 to the 4th, right? Then bring down the x minus 4. And then I get 2 to the x plus 2. The bases cancel. And then I'm going to multiply these two. And then x plus 2 equals 4x minus 16. So then after I distribute the 4, right, then I'm going to subtract 4x to both sides. I'll bring that up here. I have a negative 3x plus 2 equals negative 16. Minus 2 from both sides. Then I get negative 18. So negative 3x equals negative 18. Divide by negative 3. X is negative and negative give me a positive. X is 6. Okay? So always writing the larger base in terms of the small one. Then this one, if I take a look, here's 10. This is the larger base. So I'm going to write this in terms of a base 10. So I know 10 squared is 100. So now I'm going to rewrite these and then cancel the 1 for 1 base. So then this is x minus 3 equals 2 times 2x minus 9. I'm going to distribute. So then that's 4x minus 18, okay? And then subtract 4x. So then that gives me what? A negative 3x minus 3 equals negative 18. Add 3. And then I get a negative 15. Divide by negative 3. And x is 5. Okay? So you're always solving for x, always getting the bases to be the same. Now if you take a look at the next guy, okay, it has... you want to write these with the same base, right? So 3 to the x, right? And then how can I write 5 with in terms of a base 3? Well, 3 squared is 9. That's already too big. So this would have to be probably some sort of decimal. Like if I take a look on my calculator, right? 3 to the like 1.3 maybe? Well, 3 to the 1.3, let's say. Well, that's pretty close to 5. Let's try, get a little bigger. All right, that's getting a little bit better. But notice, I'm just guessing. I don't know the answer, okay? I know it's not quite 2, because again, 3 to the 2nd power, right? The exponent would give me 9, which is way too big. So 3 to the 1.5 is approximately 5.19 something. But that's just a guess. I want the exact answer. So here's what we're going to do. if you have an expression, right, an equation where you can't rewrite each side with the same base, what you're going to use is logarithms, okay? You're going to take the common log, okay? So if you remember, we did a bunch of this in IXL. If you can't rewrite it, what you're going to do is do log, right, base 3 of 5 equals x, right? So remember when we were going back and forth, okay, and rewriting them? These two are equivalent expressions, but if you notice now, x equals this expression, okay? So now you have to put this in your calculator. Now, the calculator, if you look, only has log, and there's no base here, right? So that means the base is 10, whereas our expression has a base 3. So we can't change the base on our calculator. So here's what we're going to do. We're going to use what's called the change of base formula, okay? And if it's a formula, it never changes, okay? What you do is you take the log of the bigger number and divide it by the log of the smaller number. That's how you're going to put log base 3 of 5 into your calculator, all right? So the calculator is going to figure out what exponent should this be when I put this in the calculator. So log base 5, close your parentheses, then you hit the division sign, and then log of 3, close the parentheses, hit enter, and there it is. So x, and we're going to, I don't know, round to the nearest, let's say, hundredth, so this would be 1.46. Okay, and if you check, and you don't have to do check, I know you all love checks, but if we did a real quick check, is 3 to the 1.46 about 5, right? Approximately 5. Well, 3 to the 1.46 is really, really close, right? It's only off by like 3/100ths, okay? Maybe a little less than that. So that's a really good estimation of the answer, okay? Better than me just guessing, all right? So if you can't rewrite, right? So can't rewrite, then you're going to rewrite, okay? Use a log. So if you notice you can't rewrite, you're going to use logs, and then you're going to use the change of base formula, okay? So let's skip down here. I'll come back to this one. See how we have 2 squared, right? Now, I know 2, I should say 2 to the x equals 9. Well, 2 squared is 4. 2 to the 3rd is 8, and 2 to the 4th is 16. If I look at my kind of cheat sheet here, okay? So this exponent has to be somewhere between 3 and 4, but I don't know exactly because I can't rewrite it, all right? So that means I'm going to convert this into logs, okay? So we're going to use logs. So the first thing we do is use logs. So log base 2 of x, of 9, I should say, equals x. Now notice, now the x is all by itself, right? So now I'm going to let the calculator do all the work. So the calculator, I'm going to use what's called, again, change of base formula. Okay, so anytime we have a formula, we're just plug it in. You're going to take the log of the big number divided by the log of the small number, the base. These are both base 10, so I can use my calculator. So that's what x is. So x equals, so now I'm going to put in my calculator. I have to use a calculator for this. You have to use a calculator. Log of 9 divided by log of 2. And we get to the near, we'll do the nearest hundredth again. So 3.17. Okay, now again, you can do a kind of check. 2 to the 3.17, is that about 9? Let's look. Yeah, it is, right? It's a little bit larger because we rounded up, okay? But that's essentially 9, right? Very close. Okay, let's look at our last one here. Number 9, right? 3, right? If we use our cheat sheet, hopefully you recognize, right? we have 3 squared is 9, 3 to the third is 27, and then we get 3 to the fourth all the way goes to 81. So there's no way that I can get 40 and rewrite it with a base 3. So I'm going to use logs. So I'm going to do log base 3, same base, of 40 equals x, right? Remember, the number over here is always your exponent, or the variable, all right? Then we use change of base, so log of 40 divided by log of 3 equals x, and then we let the calculator do all the work. So now I'm going to do log of 40 divided by log of 3, and we hit enter, and then we get to the nearest hundredth, 3.36. That's your answer, okay? Now, if we take a look at the next one, there's just an extra step here, okay? If you look at this one, okay, 10 and 19, there's no way I can rewrite 19 with a base 10, okay? Because I know 10 squared is 100. That's way too big, all right? So I'm going to take the log base 10 of 19 equals 3x minus 1, okay? And then what I hope you recognize is this is a base 10, right? So here, this is really just log of 19, I don't have to write the 10, equals 3x minus 1, all right? Then what we're going to do is log of 19, I can put in my calculator because that's a base 10. So log of 19, right, gives me that decimal. Okay, so that's 1.278, and I'm just going to put dot, dot, dot. I'm not going to round because I'm not done yet, okay? But I'm going to let my calculator do most of the work here. Now, if I'm trying to isolate x, I'm just going to add 1 first. So on my calculator, I'm going to leave the decimal I had, add 1, and then I get 2.278 equals 3x. And then to solve for x, just like I normally would, it's just that this number happens to be a very not nice decimal, I'm going to divide by 3. So now I'm going to take my answer, 2.278, and so on and so forth, divide that by 3, and then x will be 0.7, and if you look, 0.75, right, 9, this is greater, so I'm going to round it to 0.76. And there's my answer, okay? Now, let's take a look here. So if I look at number 11, again, I cannot rewrite this. So in all these cases, since you can't rewrite it, you're going to take the log, okay? Rewrite it in log. So this is log base 10 of 6 equals 2x plus 5. That whole thing, right, is your exponent. So it's going to be on the right-hand side. Then this is log base 10, so I can use my calculator. So log of 6. So just like we did up here. So now I'm going to do, right, log of 6, which is 0.778 equals 2x plus 5. And then I'm going to solve for x. So I'm going to subtract 5. Okay, so that's going to be just minus 5 on my calculator. So I get negative 4.221 dot, dot, dot. And then I'm going to divide by 2 to isolate the x. So divide by 2. And then I get negative 2.11, okay? Because this is 0, so I'm not going to round up. I'm just going to leave the decimal like that, okay? Now, I think you have one that's a little more complicated on the homework like this, but otherwise, they're all very similar. What I would suggest is either you're taking notes with me, or you can use my printed, the copy of the notes that I'm going to post to Schoology, and use that to help you on your homework, okay? Now, your homework is attached to the file, okay? So if you look, I took this from the textbook. So what I have you guys doing is numbers 21 through 33 odd. Okay, and I will post the answer key to Schoology as well. There will be a folder, okay, that has an answer key. And the expectation is you guys are checking your answers, okay, if you would like full credit. And so because I'm not there with you, it's super important that you check your answers so that you know you're understanding the material that we're going over, okay? I hope you are all doing well. And if you have any questions, please feel free to email me. I will try and put together a video to quickly answer your question and shoot that email back to you, okay? All right, that's it. I will have another lesson for you guys tomorrow, all right? Thank you.